Practical solutions to the first world problems by the Everyday Tinker.
Hi everyone! I'm sitting next to my beloved HTPC. She's called Blackbox because she's black and she is a little bit boxy looking. I've built it a while ago, a few months ago, and I'm very satisfied with it. But only one thing is not very cool. The GPU is not very cool. Well, it's GTX 750 in the Maxwell architecture, so I like it very much. It's a low power component, and the low power consumption is the theme of this build. But it reaches high temperatures. So right now I'm running a Unigine Valley benchmark in the background, and after 20 minutes the temperatures reached 81 degrees Celsius. And I'm not very cool with that, because they are not cool. So I've decided to replace one fan. Let me bring it. I'm back. So I've decided to replace one of these with one of these. What's the difference? This is a static pressure TB Silence fan, which I was quite fond of, but apparently it's not doing the job. This is a Noctuas Silence S12B. I love Noctuas after I've replaced one of the TB Silence PWM fan with a fan similar to this but PWM driven, and I got much lower noise. So I thought I will install two of these airflow optimized fans in the push configuration, in the configuration to have a positive pressure in the case according to the Silverstone recommendation, and I will get lower temperatures. So let's get to work and let's see if I am successful in getting this GPU cooler. While I am replacing the fans, I will give you a guided tour through the ML07 Silverstone case. I've decided to go with this one mainly due to the wipe factor. So the idea was to place this computer in my cabinet in the living room, and you know, nothing ugly goes there. So when I wanted to have a PC, it was more or less the only choice. You could go with the similar, more aggressive design, also from Silverstone. You know, the Raven, the Raven case. But this is virtually the same stuff, and this one is a little bit cheaper. However, it does not come with any fans, and it does not come with any dust filters. So this may be a disadvantage for this particular case. You can use this case either in the horizontal or vertical orientation. I'm using it in such scenario. You have only one fan grill on the top, and you have two fan grills on the bottom. And there is yet another ventilation hole, ventilation area. This is dedicated to the PSU. The main theme for this build was to have a machine which is capable of 1080p gaming. Maybe not in the ultra settings, but high details would be nice for the contemporary titles. And also I wanted this build to not to put much strain on my energy bill, because I have also put some drives there with the data that I want to share across all the computers in the household, and hence I also plan to keep it up and running for longer periods of time. So when choosing the components, I was choosing components with low TDP, and this made me quite confident in being able to run this case in a fanless mode. And you could do this, but you could do this when only running this in the vertical orientation. When you are running this in the horizontal orientation, as I do, most definitely you need fans. You need to install a fan here, so you can provide a fresh air to this part of your build, which contains most of the components. So most probably you would have a SSD here, you would have a hard drive here, 3.5 inch. If you have one, you have a PSU here, a motherboard, and a CPU and RAM. So it's nice to have some airflow in here. So I've installed, in the beginning, I've installed PWM fan from Enermax TB Silence. And quite frankly, I wasn't satisfied with the choice. So of course the airflow was very decent. There is some static pressure that this fan can provide. However, when installed in the horizontal position with the coil against the steel case, I've heard a very significant rattling. And it was driving me mad, because the second theme for this build is to be silent. Once again, this is a living room computer. I do not want to hear it when I'm watching a movie, for example. And I don't want to hear it when it's running as a small network attached storage, which sometimes I use it for. So I've replaced it with a PWM fan from Noctua, the airflow oriented one, and it was a great choice. You can hardly hear the thing, even if it's running at full speed, which it's not that high. And actually it has much lower minimum RPM value. The problem is with temperature in this compartment. This compartment contains only a graphics card. If you install it there, it's a very interesting solution. So you've got a PCI riser here. You are putting your GPU here, and it's installed top down against this plastic piece. When I had the fanless design at the beginning, I thought, okay, so there is a fan, and if there is a need for a fresh air, there are huge openings at the bottom, so it will manage. Now it won't. So I've installed two constant RPM Enermaxes TB Silence, and it was quite fine. You could hear the sound of the air being sucked into the case. So when I had two of these installed one side by side, so I decided, okay, I've got a small GPU, which the card probably extends till here, so I will be fine with just blowing some air here in this compartment, so the hot air is not accumulating here. The fan on this side will manage to get some fresh air from the bottom. Everything will be fine, so I've removed this fan. And just recently, when doing some temperature testing, I found out that I'm reaching over 80 degrees Celsius in such setup, and that's why I've decided that it's time to change. As I was so satisfied with the Noctua PW airflow fan installed here, I decided that okay, I will go with the constant RPM versions of this fan installed here. I found some second-hand fans in the set of two, so I thought to myself, okay, it's a dirt cheap, I will buy it, dirt cheap for Noctua, of course. I will buy it, I will install it, and it would be great. So this is what I'm doing right now. I'm installing these two fans to provide fresh air to this compartment. As you can see, there is not much connection between this compartment and this compartment, so actually you need some ventilation in both areas. So when building inside this case, remember to equip yourself with some low RPM airflow oriented fans, so you can provide some fresh air here and here, especially if you are running in a horizontal orientation. One more thing, PSU installation. PSU goes here you need a SFX PSU, which is quite a disadvantage because these are quite expensive. I have a Silverstone one. I have a Silverstone 300 watts. So many of you may say, okay, so this is worth nothing because it won't be able to run anything. Well, actually, when I'm measuring the amount of energy that I'm using when running the system at full load, it's around 100 watts. We all know that the PSUs are most efficient when they are running at more or less 50% of their maximum, the maximum power that they can deliver to the system. So I'm far away from there, even at full load. So I can safely add some more components here, and I plan to do it in the future. When installing the PSU, first I've installed it so it can draw air from outside the case and push it out by the means of the openings here at the bottom. Well, in my case it's the right side of the enclosure of the chassis, and it's working fine. However, I have a 3.5 inch hard drive installed here. You can see there is a cage for. There is only one cage in this case which can accommodate this size of a hard drive, and this little boy was getting hot, and I wanted to make it a little bit cooler. So I decided to flip the PSU, so the intake fan actually is inside the case. There is a small opening, small space here, so when there is a need to ram the fan in the PSU, it will draw the air from inside the case, and by adding some additional air movement, airflow in this area, I've managed to reduce the maximum temperatures of my hard drive by 8 degrees. One more thing. So far I'm using a positive pressure setup in this case, so all the fans are intake fans, but the PSU fan, of course. And I'm doing this because this is the recommendation from Silverstone. So they clearly recommend to have a positive pressure in all their cases, which makes sense, of course. But in such scenarios, you may think about adding some dust filters to your setup. Let's take a look at a few more shots of the case that we are working with right now. And so it's actually I was a little bit disappointed, and I will tell you why. This is the first Silverstone case that I own, and I was expecting a very high quality from this case, and actually it looks good. I will tell you, it looks good from front. The top and the bottom is also nice, but this area, left and right areas, are made of cheap plastic, and it doesn't look good, right? And when this piece meets this piece of the brushed aluminium meets this piece of cheap plastic, it looks bad. It's not well fitting together, so it's not that pretty. One more thing. These connectors, two USB 3.0 connectors, audio connector and a connector for the microphone, and the two buttons here, one for the power, second for the reset, and the LED openings. Honestly, when you look at it from a closer distance, they look cheap, especially the USB ports. They do not fill the openings in the plastic faceplate perfectly, and it's also a little bit disappointing for the Silverstone case. There is yet another disadvantage to this case. Actually, you cannot remove the side panels, the left and right side panel, which could be useful because there is a mesh behind of this, which you could potentially use. You can see there are ventilation holes here, and if I was able to remove these pieces, probably you could fit some 80mm fan here on the right side and on the left side. Yet another thing that it may consider you from the thermal perspective, the two 2.5-inch slots for SSDs, hard drive, whatever you wish, are located on the next to the backplate of the GPU. So if you have a GPU which generates a lot of heat, then you are effectively frying these two, and this is yet another reason why you would like to have an enforced airflow in this case. Look at these buttons, they look cheap, really. Now this case, it's not small. When you look at it from the outside, when you consider it as a part of your audiovisual equipment, it's a huge piece. For a PC case, it's a small one. Well, you need to take shortcuts, and I believe that putting water cooling in this case, it's a hard task. It's not worth it. You should go with good fans, good quiet fans, and if you are running in a horizontal position, you need them. Okay, so it seems that the work is done. The Noctuas are installed. Let's see what are the results. So it's a day after. I have spent half of the night trying to figure out what went wrong. Because obviously something went wrong. After installing a second fan, I got very similar readings compared to before. The temperatures are, maybe you can see it, more or less the same. So the max is around 80 degrees centigrade and 80 degrees of Celsius, and well, there is no much improvement observed. I should have a better airflow according to the specification of the fans, more or less by 50%, and there is no visible improvement. So I thought to myself, okay, maybe the problem is with this cabinet. Maybe it behaves like an oven, and there's not much ventilation here, no holes, so maybe a high temperature, maybe the hot air is accumulating somewhere here, and then it's circulating back into the case, and that's the reason why. That's the source of the problem. So I've removed the case from the cabinet, repeated the test, and once again, as you can see, 80 degrees Celsius. Not that good, especially considering that this is a Maxwell chip and a low-powered one. So I've made some few more experiments, and then magic has happened. So I can show you what kind of magic is this. This is the case in its default desktop orientation, 80 degrees. So let's take a look, let's check what happens if I put it vertically. Okay, so we are doing like this. Yep, okay, so the case is vertical. And now, let's see what's going on. Let's check. Let's get a little bit closer. Okay. Can you see it? We've started with 80 degrees and it's going down. 73. And I can tell you that this is going to proceed like this till it reaches 65. So more than 10 degrees of difference between the default orientation, well, the desktop orientation, and for me this is a default orientation for this case, and the alternative horizontal orientation, like this. Yeah. So the thing is obvious. The hot air is gathering inside the case. It's being circulated over and over in the graphics card heatsink and fan, and it has problems with getting out of the case. I have some ideas how to fix it, and it would involve modding the case probably, and well, it's a good material for the next episode. Can you see? 69 degrees and falling down. And right now it behaves according to the expectations. This is the temperature that I would expect from the overclocked GTX 750. There is an old proverb that says that when you have a hammer, everything looks like a nail. And this was the case with me thinking about modding a case. I bought myself a Dremel, so everything looked like an opportunity to use it, but it wasn't necessarily the best solution. After some considerations, I came up with an idea. Okay, I will try some combinations, right? Because initially, I will just use I will use two fans as a visualization, as an example of what I'm talking about. Actually, this is exactly a kind of Noctua that I've put in the case, two of them. And this is an Enermax TB Silence. This is a PWM version. I'm using the constant RPM version, but still it serves the purpose. It looks exactly the same. So I've started with a configuration like this. So both of the fans were pushing the air into the case according to Silverstone recommendation. But apparently there was a problem with hot air accumulating on the top of the case and not being able to escape. So the idea was to take one of the fans, presumably this one, because the GPU fan is located over this particular fan, to put it like this, right? To have this fan pushing the air into the case and have this fan pulling the hot air out of the case. And after some experimentation, it appeared that it improved the quality, it improved the temperature. So let me check my notes. We started with 80 degrees Celsius, and after just flipping this one fan from this position to this position, I've managed to reduce the temperature, maximum temperature, to 76 degrees. I was very much compelled to continue my experimentations because I thought maybe I will be able to get even better. Remember that I'm using this just for as an example. So in fact, I started with two Noctuas, and these are the low pressure, high airflow fans. Let's use one of these higher pressure fans, Enermaxes, to get the hot air out of the case and leave Noctua as the fan which is pushing on the GPU. So I've experimented with this configuration, and I've managed to get even better results. 73, 74 degrees Celsius. So once again 2 degrees lower compared to the first experiment. The next idea was, okay, so this is a high static pressure fan. Maybe it would be good to have a stream of cool air targeted at the GPU. And let's use the airflow to suck a little bit of it out of the case. So I've ended up with such a configuration. So this one is blowing on the GPU. This one is sucking the air out of the case, right? And the results were even more promising. So I got maximum temperatures of 72, 73 degrees. So the next idea was, okay, so maybe let's have both of them pushing the air into the case, actually in this orientation. So this one is pushing on the GPU, this one is simply pushing into the space next to the GPU to kind of push the hot air out of the case. And actually, the results were not bad, but were worse when having this configuration, right? So this pushing, this pulling. The results were around, max temperature was around 73, 74. So then I came to a set conclusion that heck, maybe I do not need these. Maybe I need a higher static pressure fans like this. So I get rid of this, left only this, but in the slot next to the original one, blowing directly on the GPU. Luckily for me, the results were a little bit worse compared to this configuration. They were worse by 2, maybe 1 degrees Celsius. So I've ended up having this fan blowing at the GPU directly, this one next to it sucking the hot air out of the case, and so far I'm quite satisfied with the results. So what is my conclusion? My conclusion is, when designing an airflow, you should start with a main theme. Positive air pressure, or maybe negative air pressure if you prefer. Design some airflows, the basic airflows that you think that will work, and then reserve a lot of time for experimentation. and validating your initial idea, modifying it on a go, experimenting a lot to have as low temperatures as possible. Prepare for yourself a set of benchmarks, repetitive tests that you could use to make sure that the results are comparable, and experiment. And that's all for today. Thank you very much for watching this video. If you like it, stay tuned for the next episodes. I would also like to apologize for the inconsistent quality of the video material. It was linked with the aberrate schedule for the video gear, and hopefully the next episodes would be in a better quality. So once again, thank you very much, and hopefully see you soon.